Hello everybody, welcome back to another AP Calculus ABC video. This is Unit 6, Lesson 6, Properties of Definite Integrals. Okay, question 1, we have a graph of f consisting of line segments and a semicircle. Evaluate each definite integral. Okay, so let's look at A. So we have the integral from -4 to -1. So we are looking to find the area under the curve from -4 to -1. So from here to right here. So we have a triangle. We know the area of a triangle is 1/2 times base times height. So our height is 2 and our base is 1, 2, 3. 1/2 times 2 times 3. So 1/2 times 2 is 1 times 3 is 3. So our area of the triangle is 3. Okay, next we have area under the curve from 2 to 1 of f of x dx. But remember, your integral your limits should be in order from lower to higher, right? So what I mean by that is that the lower number should be the lower limit and the bigger number should be the upper limit. So 1 is not greater than 2. And so we're going to have to use one of the properties to get the 1 to go in the lower limit and the 2 to go in the upper limit. So to do that, we would just put a negative, and then now we can fix our limits. So the area of 1 to 2 is right here. So 1/2 times base times height. So our base is 1, our height is 3. So 1/2 times 3 times 1 is going to be 3 over 2. But remember, we have a negative since we switched our limits. Okay. Area from 1 to 5 of 2 times f of x. Remember that if we have a constant k in our integrand, we can move it to the outside, right? So this expression is equivalent to this. All right, from 1 to 5, we have a trapezoid, so I think that'll be the easier way to solve this. So as we saw before, we have a height of 3, so that's going to be our width. Our width is going to be 3. And then remember the 2, right? So 3, our width, times L1 plus L2 over 2. So L1 plus L2. So we have a side length of 2. And we have a side length of 4. Alright, so that's going to equal 2 times 3 times 2 plus 4 is 6 divided by 2. 6 divided by 2 is 3. 3 times 3 is 9 times 2 is 18. So our area is 18. Alright, integral from -4 to 5. So we know the area from -4 to -1 is 3. We don't know the area of the semicircle. Sketch a graph of the definite integral. Evaluate the integral with the graphing calculator. Okay, I'm gonna do my best to try and graph this. But it might not be the most accurate drawing. Okay, we have, for question 2, we have integral from 0 to 3, negative square root of x plus 1. So we know a square root graph is something like this, so this should be negative. So negative would be something like this. And then write a reflection over the x-axis. And then we have plus 1 on the inside, which tells us there's a shift to the left one. So this tells me that it goes something like this, something like that, right? And what we're gonna try to find is the area from 0 to 3. But we get to use a calculator. So let's do that. Alright, so if you don't know how to find an integral using a calculator, I'm gonna show you. So math, and then we used 8 for derivative, but for integral we're gonna use 9. Now we plug in our lower limits. So 0 and then 3, and then the function. So negative square root of x plus 1 dx. And that gives us negative 4.667. Negative 4.667. Okay. Next, we have integral from negative 2 to 3 of the absolute value of x plus 1. Alright, absolute value graph is like a V, and the only transformation we have here is a shift to the left. So should be something like this, right? It's linear. As x increases by 1, y increases by 1. As x decreases by 1, y decreases by 1. So yeah, something like this, right? And we're asked to find the integral from negative 2, so right here, to 3. Okay, so we can obviously actually solve for this. We can solve for this because we have some geometric shapes, but we are going to look at it on the calculator since that's what the question is asking us to do. So we have negative 2 to 3 of how to do absolute value. You go to math, number, absolute. So we have x plus 1. And we get approximately 8.5. Or if you want, 8.499. All right. I don't know what's going on here. Okay. Last one we have integral from 1 to negative 3 of negative x over 2 plus 1. So we're going to ignore the integral for now and graph the equation. So negative x over 2 plus 1. So we have a point at 1, right? So if it's negative x over 2, then that means as x increases by 1, y decreases by half. So let me think. Should look something like this. All right. Right, so we have as x goes as as x goes 1, y only goes down 1/2. Okay. So now we can look at the integral. So we're going to find the integral from negative 3 to 1. Now I know the question is it has limits, written reversed. But when you put into a calculator, you don't have to worry about that. Okay? So that's what I want you to know, that when you plug in your limits into the calculator, you don't have to worry about putting the negative and changing the signs. The and putting a negative sign. So negative x over 2 plus 1 dx, and we get negative 6 as our answer. Right? Alright. Cool. Alright, so now we have a different type of question. So let's see. We have f and g as continuous functions, which will produce the following indefinite integral values. So, okay, so let's take note. Okay, we have this. All right, cool. Find the following. Integral from 2 to 7 of 2 times f of x. So 2 to 7, we have that right here. And then we're just going to apply some of the rules, right? So constant goes on the outside. So 2 times negative 5 is negative 10. Okay. Negative 3 to 2 of f of x. We have that right here. So 4 times 2 is going to be 8. Negative 3 to 7. So remember, if you have something like this, negative 3 to negative 2 plus 2 to 7, that is equal to 2 to 7. Sorry, negative 3 to 7. That is equal to negative 3 to 7. And so we're just going to add those values. So 2 minus 5 is negative 3. And then that's it, right? Okay, from 2 to negative 3 of g of x. So we have 2 and negative 3. And all we have to do is flip the limits. So that's why we put a negative on the outside. So that gives us negative 6. Okay. Integral from negative 3 to 2 of g of x dx minus integral from negative 3 to 2 of f of x dx. That is how we can split apart the integral. So from negative 3 to 2 gx, we know that's 6. Negative 3 to 2 of f of x, we know that's 2. So that's going to give us 4. Okay, absolute value of 2 to 7. We know that from 2 to 7 of f of x, that gives us negative 5. So we're just going to apply the absolute value. So that's going to be 5. So negative integral from 7 to 2. We know that those limits are in the wrong place. It should be from 2 to 7. So we're going to put another negative on the outside. So from 2 to 7, f of x dx. Negative negative cancels out. 2 to 7 is going to give us negative 5. Okay. Find the following. So again, this is similar to the last pair of questions we did. So we have f, and g. So let's look at 12. Integral from 2 to 2 of g of x dx. Well, one of the properties is that the integral from a to a is going to be 0. Okay, integral from 6 to 1. Let's rewrite the limits appropriately. So from 1 to 6, we know it's 4. Sorry, from 1 to 6 of g of x is 8. So we get 8 and apply the negative. Okay, 3 times integral from 1 to 2 is of f of x is given as -2. So all we're going to do is 3 times -2 as -6. Integral from 2 to 6. 2 to 6. All right, how can we do that? Well, I see we have a 1 here. We have 2, 1, and a 6. So 6 is our upper limit. So this one's fine. But if we could get this 2 to be our lower limit, that would be perfect. So it seems kind of counterintuitive to change the integrals limits as they're already right. But in this particular example, we actually want to have 2 as our lower limit instead of 1. And so we're going to do integral from 2 to 1 to negative of f of x dx plus integral from 1 to 6 of f of x dx. From 2 to 1, okay, so we know that from 1 to 2, it would be -2. But we are now going to make this +2. Plus integral from 1 to 6, which is 4. +2 plus 4 gives us 6. Question 16, we have integral from 1 to 6 of f of x minus g of x, so we can split that up. 1 to 6 of f dx minus integral from 1 to 6 of g dx. So it is given that we have 4 here, and then from 1 to 6 of g is going to be 8, so -8, and that's going to give us -4. Okay, integral from 1 to 6 of 3 times f of x minus g of x. So again, this is exactly like last problem, but we're now going to have, okay, let me rewrite that. I'll put the constant on the outside. So we have this, that's a 6, minus 1 to 6 g of x dx. Okay, 1 to 6 of f of x is 4. So 3 times 4, and then minus 1 to 6 is going to be 8. 12 minus 8 is 4. And I'm going to erase this for the next question. Right here. Now, for the next question, you might be tempted to say that, okay, sure, let's find the integral from 1 to 6 of f of x minus g of x. So f of x would be 4. Drawing tool works. 4, and then minus g of x, which is 8, absolute value, which is 4. That would be wrong. That would actually be the answer for the next question, 19. As for 19, the process you would do is you would solve for the inside first and then apply the absolute value after. So that's what you would do for number 19. For number 18, remember that an absolute value applied on the interior of an integral is the area has to be counted as positive. And so I think that, you know, I thought it was 4, right? But, you know, looking at it closer, I don't really know if we can make that assumption. We don't know what the graphs look like of f of x minus g of x. So that could, you know, totally change how, you know, we view this problem if we had the graphs. And so I don't think with just, you know, 2 values, we're going to be able to find, you know, the integral from 1 to 6 with the absolute value on the inside. You can absolutely do that with the absolute value on the outside, but on the inside, I'm not sure if we can make that assumption. So we are just going to write, for the sake of this, we're going to write no answer. Okay, for our last question, we have an FRQ, it looks like. The graph of the function f is shown above. Let g be the function defined by g of x equals integral from 2 to x, f of t dt. Find the average rate of change of g from -4 to 6. All right. We already know what our average rate of change formula is. We should know what it is. So we're going to find the values of both g and -4 and g of 6. G of 6 is the integral from 2 to 6 of ft dt. So from 2 to 6, that is going to give us g of 6. So area of a triangle is 1/2 times base times height. You have a base of 2, height of 1. 1/2 times 2 times 2 is going to be 2. And then over here we have square is just 1, right? And then 1/2 times 1 times 1 is 1/2 for the triangle. And again, we want to remember that any area below the x-axis, we are going to consider it negative. So it is going to be -2 plus 1/2 plus 1 is -0.5. Okay, g of -4 is the integral from 2 to -4 f of t dt, which is equal to negative integral from -4 to 2 f of t dt. From -4 to 2, -4 to 2, we're going to use that. Yep, that right there. Okay, perfect. Area of a triangle, 1/2 times base times height. Height is 4, base is 2, so 4 is our area. We can use the area of a trapezoid to solve for this area. So our width is 2. L1 is 1, 2, 3, 4. 4. L2 is 3. So we have width 2 times L1 plus L2 over 2. So that cancels out. And this should be 3, not 2, right? Because our side is 3. So that gives us 7. So positive 4 minus 7 is going to give us -3. So g of 6 minus g of 4 minus g of -4 is -0.5 minus -3, which is +3, over 6 minus -4, which is 10. So that gives us, apologize, this should be +3 because we had a negative right here. So it's +3, which would make this -3, which would give us -3.5 over 10. All right. B, find the instant rate of change of g with respect to x at x equals 5, or state that it does not exist. So fundamental theorem of calculus, g prime of x is equal to f of x. G prime of 5 equals f of 5. So we can see right here, f of 5 equals is equal to 1, +1. On what intervals, if any, is the graph of g concave down? So G concave down means G prime double prime of x is less than 0. So we know G double prime of x equals f prime of x. So f prime of x less than 0. So let's look at the slope. I'm going to erase all of this. Let's look at slope of the graph. So we have negative right here, 0, positive, 0. So we have negative from -4 to -1. And so -4 to -1 because G double prime of x less than 0. Find all x values in the interval -4 to +6 at which G has a critical point. And then classify each critical point as min, max, or neither. So critical point occurs when G prime of x equals 0, which means f of x equals 0. So when does our graph have zeros? Right here and right here. So -2 and I believe that was 4. Yeah, 4. So you look carefully, x equals -2, our graph goes from positive to negative. So local max because G prime changes signs positive to negative. And then at x equals 4, our graph goes from negative to positive. So this would be a local min at 4 because G prime changes signs from negative to positive. So that is the entire lesson. I hope this was helpful. I apologize that I couldn't give you the best answer for number 18. But yeah, pretty straightforward lesson as we continue to get closer into the second half of calculus. Thank you so much for watching. If you have any questions, please let me know, and I'll see you in the next lesson.